Hey students, this is the second part of the review video for Spiral 13. Although depending on the year, this may actually be Spiral 1213 that you're looking at. And we're looking at EVT, IVT, MVT, and FF prime, F double prime stuff. For the first one, we've got f of x is ln of x over x, and we're talking only in the positive part, so we're ignoring the domain issue that we have in both cases here. So what we've got to think about is about whether we're increasing or decreasing, and what this might look like. So let's take a look at some of this stuff. To decide if things are increasing or decreasing, we have to decide what f prime is when we compare it to 0. Because if we're greater than 0, we're increasing. And if we're less than 0, we're decreasing. If we're equal to 0, we're constant, but that's only going to be for a moment here if we have anywhere. So we've got to take the derivative first. So we've got f prime of x. And this is a quotient rule, so we've got the bottom times the derivative of the top minus the top times the derivative of the bottom. And that's all over the bottom squared. When we do this out, we've got 1 minus ln of x over x squared. We've got to care about places that we have either values that would make this undefined or values that would make this 0. Undefined would be at x equals 0, which we can't have for ln anyway. But because we're not considering that, we don't really have to worry about that for this particular problem. The other thing we're going to have is if 1 minus the natural log of x is equal to 0, and that's going to happen when x is equal to e. So what we really have is this situation here where we have 0 as this firm stopping point we're not caring about for this function, and we've got e to take a look at as well. So I've got to know what happens before e and what happens after e. A nice point to plug in might be 1, and this is really nice because at 1, the ln part's going to go to 0. So f prime of 1, if I plug that in, I get 1 minus 0 over 1, which gives us a positive value. That means that f is increasing between 0 and e. Okay, so I'm going to take a look at this. I don't see anything that immediately tells me this is the answer that I'm looking for. I do know that we can say the decreasing one does not work, and that the other one that is decreasing before we get to e doesn't work as well. Okay, so let's see what happens after we get to e. So after we get to e, we're looking at, I don't know, maybe 3 as a value. That seems pretty good, although it might be a little bit better to use something with e, depending on how your brain works with ln stuff. But if I try 3, we've got 1 minus ln of 3, and on the bottom we're going to have 9. ln of 3 is a number that's larger than 1, so we're going to have a negative value on top and a positive value on the bottom. That gives us a decreasing thing after e. That tells us that we are decreasing for all values greater than e. Looking at our second problem on this page, I see all kinds of funky mathematical language that suggests this is going to be an EVT, IVT, MVT problem. And in looking at this, we're told it's continuous. Okay. So that means that these two are automatically able to be used. There's no c for which f prime of c is equal to 0. Okay, so there's no value that a derivative is equal to 0. Let's take a look at the points they give me. So they give me 2 points. They tell me that we've got negative 2 at 0. We've got positive 2 at 0. I like that my graph is super even. What they're suggesting here is that since the average rate of change between these two is 0, if the MVT could be applied, this should be true. So this tells us that MVT doesn't work here. And what I'd like to just quickly think about is what would cause MVT not to work. And the only reason that that would not work is if this is not differentiable. So remember that EVT, IVT require us to be continuous. MVT requires us to also be differential because we're working with derivatives. In this case, we're looking at something that MVT does not work, therefore it is not differentiable. So let's take a look at these values. This says the derivative is positive. Nope. This says the derivative is negative. Nope. This says the derivative exists. That's kind of what we're looking for, because we're talking about something that's not differentiable. That means we have at least one place on this graph that we can't take the derivative. In other words, the derivative doesn't exist. So I'm going to put a circle around that just for a moment and just double check. Derivative exists, but not continuous. So that would be if we had a derivative that we had something like this. And that would give us derivative values for all these places, but would not give us something that would definitely work. So this is not going to be what we're looking for. We really care about that existence part. And this other one, we're told that for some value, f prime doesn't exist. Ooh, I really like that one, because it could exist. And, you know, my favorite part about this is that I totally did not read the instructions here again, which we talked about in class the other day. We're looking for the one that must be true. The one that says that it exists everywhere can't be true because MVT doesn't apply. And that really gives us that e-value. I'm glad that I kept going with those and reading those instead of giving you a wrong answer for that. So just to summarize, since MVT does not work, this thing cannot be differentiable. The one that describes this not being differentiable is saying that some value between these 2 points, the derivative doesn't exist. That's what it means to not be differentiable.